Hi, welcome back to part 3 of our arc length lesson for multivariable. So Mr. Wernout, an avid golfer, hits the ball with a velocity of 113 feet per second. I knocked the crap out of that ball at an angle of elevation of 15 degrees with respect to the ground. Find a vector-valued function for the path of the ball. Now, this is the vector-valued function for the path of a ball, right here. And again, it is a trace for us. So I just want to find this equation. All I have to do is just plug and chug in. So we would get r of t equals v naught. My initial velocity is 113 cosine of 15 degrees. And that's going to be ti in the I direction plus over here, let's see here, h naught. Well, I'm hitting the ball, my initial h is 0 plus v naught, so it's 113 sine of 15 degrees t minus 1/2. Well, gravity is just is going to be 32. We're in feet per second, so it's 32 feet per second. So that's 32 t squared. Weird looking J. Alright, so there's my equation right there. Now I'm going to clean this up quite a bit. And if I plugged all this in my calculator, which I already did, so this is going to give us 109.15 t in the I direction, plus over here in the J, that becomes 29.25 t minus, and that's just 16 t squared in the J direction. I messed up my J up there. Nobody told me. Alright, so remember, from physics, this is the change. This is like my x of t. This is my y of t. Now the next question says, find the maximum height of the ball. Well, we've done this before. That is a, if I want to find the maximum height, if I knock a ball up in the air, the maximum height, this is where the change in y is 0. So that's what we're going to look for. So I have to take the derivative here. So we get 29.25 minus 32t equal to 0. And we get t equals, and I'm going to go ahead and type this in my calculator. So I am going to take 29.25 and divide that by 32. So this doesn't tell me what my height is. This tells me where it occurs. So it occurred at 0.914 seconds. This is when the maximum height occurred. To find what the height was, I have to plug that into my y of t equation. Y of 0.91914. And if we plug that in, we're going to get 29.25.914 minus 16 times 0.914 squared. And if we type that in our calculator, 29.25 times 0.914 minus 16 times 0.914, and I'm going to square that, and we get a maximum height of 13.368 meters. And there's our maximum height right there. Oh, not meters. I wish it was meters. It's me golfing. Feet, sorry. Mathematicians, we don't care about meters or feet. We just want to get a number. Alright, to find the range, this is how far the ball travels. So we've done these before in pre-cal and in calculus. So we need to find when y of t equals 0. Now notice, some people say, can't we just double the time here? Yes, you can. But that's only because we start off with an initial height of 0. We're not always going to start off with an initial height of 0. So I'm going to do it the way that will work for every time. So we want to find out where y of t is 0. So that's going to be where 29.25t minus 16t squared equals 0. And I am going to use my calculator. Graph it. Let me see here. I'm going to delete this function from earlier, and that's going to be 29.25. Now this time I have to use x minus 16x squared. We get our function. Notice we do get 0, so 0 will be one of them, and I got to find this other one right there too. So menu, I am looking to analyze the graph, looking for a 0. Lower bound, I'm just going to click here, and I just scroll. Whoops, didn't click on it, sorry. Clicks, upper bound, and it tells me the point 1.83 right there. So I'm going to get 1.83. And yet, it is pretty much doubled that, which it should be, but remember, that's because we're starting it at a height of 0. If I start at a height of 16, we would get different answers. So we want to find the range. Well, if I left t equals 0, that wouldn't be too far. That's where I hit the ball. This is how long the ball is in the air. This is the time in the air. So I am now going to plug that into the horizontal component, which was x of t equaling, that's this part right here, 109.15 t. And I get x of 1.83, 109.15 times 1.83, and let's see what that gives us. Clear that out. 109.15 times 1.83. Yep, that's not letting me do anything. You're all right there. Sorry. 109.15 times it by 1.83, and we get 199.745 feet. Not very far for the Golf Pro, Mr. Warnow. All right, the last one finds the arc length of the trajectory. Now, remember, this is how far down range. So if we're hitting the ball, basically, starting at 0, this distance right here, that is 199.745 feet. This right here, my maximum height, we said that was 13.368 feet. Now what we want to find is this arc length, L. So to get that, well, that's an L. To get that length, that arc length, or S, we're going to use our rule, our new integral. From 0, that's where I'm starting it, to 1.83, where I started, where I finished, and that's going to be the magnitude of r prime of t. Of our velocity. Remember, this is my velocity graph, right? That's my velocity. The magnitude of the antiderivative of velocity is going to give us total distance traveled here. So we need r prime of t. So let's go ahead and get that. R prime of t. Ready? There's r of t. So we get r prime of t. We would get 109.15 comma over here 29.25 t, so 29.25, not the t goes away, minus 32 t. So to get the length, 0 to 1.83, we need that magnitude, 109.15 squared, plus this equation squared, don't simplify, minus 32t squared dt. And we just type that in our calculator. Now again, I'm going to go back to my home screen, homies, which I am, menu, calculus, looking at that integral from 0 to 1.83, the square root of, delete, nope, don't want to delete it all, I don't know, it's clear, there we go, the square root, there we go, and I'm going to go and use parentheses so I don't make a mistake, 109.25 squared plus, no 3 there, plus, open up another parenthesis, 29.25 minus 32 x I'm going to use x this time. I could use t if I wanted to, but I'm going to use x squared. I just got to make sure that this is also an x as well, your differential, x, and I get 202.296 feet. And that is the total distance that ball traveled. Right there. Alright, so I hope you guys enjoyed these little videos right here. Click like. I'll see you later. Bye-bye.